Welcome to another stair building education series. Let's go ahead and jump right into it with our first video. In this video, I will provide you with 4 different stairways. 2 of them will be fine. The other 2 will have a problem. And of course, this problem is usually going to be provided to you compliments of the stair builder. And this seems to be a common problem. I've seen it numerous times. And is it going to provide you with an unsafe stairway? I doubt it. But once you're aware of it, you can make the necessary adjustments and compensate somehow so that it doesn't happen. At least it doesn't happen on any of your projects. So for example, this stairway here does not have any tread variations. Each one of these steps is 11 inches, and each one of these steps does not have a nosing. However, that's not the case here. The upper deck actually has a 1-inch overhang. Now, this is something you're probably rarely going to run into. Most of the time, the steps will have a nosing on them, but the deck won't. However, I thought I would provide you with this example anyway. Now, for those of you who are not familiar with building codes, the building code measurements for a step, or the depth of a step, will be measured from the upper, farthest protruding section of the step to the farthest projecting point on the step below. So even though we have an 11-inch wide step here, your building inspector and the building codes for something like this is going to count this as 10 inches. And is something like this going to be the end of the world? No, I doubt if most, I don't want to say all, but I doubt if most building inspectors are even going to catch it. Except, of course, for those watching this video. And the good news for something like this is an easy fix. You simply pop this board off, rip it down, reinstall it, and you are done. Now here's another stairway you are not going to have a problem with. This one here has the 1-inch nosing all the way down. So we have 11 inches off of the front of the nosing on the lower step to the front of the nosing on the upper step. And of course the rest of the steps are the same size. So this one here is going to be fine. And this is what you would be shooting for if you were going to put a nosing on each step. And of course, this is what originally inspired me to make the video. And of course, this would probably be the most common problem or mistake made by either the stair builder or the deck builder. And of course, it provides us with a 1-inch longer tread. Now, something I need to point out, I know some of you people are going to get a little creative while you're watching this video, is that I wouldn't suggest to reduce the size of this by cutting 1 inch off of the stringer and reducing the size of this step by 1 inch. And even though that might be accepted by your local building department, it could create problems for the people who use the stairway. You start walking up a set of stairs with a nosing, and you come to a step that's going to be 1 inch shorter and no nosing up here. You could actually create a trip hazard. So I think if it was me, I would suggest to either use the nosing throughout the entire stairway or no nosing throughout the entire stairway. So just keep in mind that sometimes, because it might work with your local building department or be within the means of an acceptable building code, it might not produce a safe stairway. So just kind of throwing that out there. So that is it for this video here. I gave you 4 examples and of course ended with the most common problem that you're going to see when building a stairway with a nosing and a deck without a nosing. Now here's a video that started out as a stairway that was going to be used for pets. Maybe a small dog that can't get on top of a couch or a bed, something like that. But then I realized that you could use this stairway for other things like trailers, maybe a small deck, mobile home, something like that. However, in this video, I'm going to do something a little different. I'm going to provide you with all of the measurements necessary to create something like this. And of course, this is the first time I've done that in one of my videos, even though I have provided some measurements in some of my other videos for different types of stairs. Now, this is actually a stairway I think most people can build. with only a few simple instructions and of course all of the measurements so that the lumber can be pre-cut either at a lumber yard or even a home improvement center or any place that would pre-cut all of your materials for you. If not, and you have your own tools, then it's going to be a little bit less hassle for those who work at these other stores. So let's go ahead and break it down and take a look at some of our measurements here. And you can use other size materials. For example, if you want wider steps, you can always use 2x8, but we're going to be using 2x6 and 1x2s. So the dimensions for our 1x2 is going to be 3/4 of an inch by 1.5 inches. And of course you have the length right here, 1 foot 10 inches and 2 foot 9 inches. And the size of our 2x6 is going to be 1.5 inches by 5.5 inches. And I mentioned using 2x8. You could always use 2x4s for this also if you wanted it to be a little smaller. And of course the sizes for our 2x6 is going to be 5.25 inches. We're going to need 2 of them. And then 1 foot 3/4 inches, 12 3/4 inches for the next 2 boards. And then 1 foot 8.25 inches or 20.25 inches for the taller 2x6. And for the next components and the last components that we're going to be showing with measurements will be 16 inches or 1 foot 4 inches for the 2x6 we're going to use for our steps or treads. And of course the bottom 1x2 will be 1 foot 4 inches wide or the same measurement as the step. And the ones on the sides will be 2 foot 6 inches. Now I also need to point out, and of course this is very important, I have not physically built one of these and would appreciate someone getting back to me if any of these measurements are incorrect. However, this is a scale model that I should be able to take accurate measurements from. Now when it comes to putting this thing together, you can do it a different way. You don't have to follow my instructions here. But for those of you who don't know what you're doing, let's stick to what I'm going to show you here. And I think the easiest way to assemble this stairway will be to put each one of these components together separately. And that can be done by simply attaching these components together with either nails or screws. Just make sure that the screws are at least 2 3/4 inches long. And if you're using nails, maybe a 16D nail would work fine. However, you will need to use smaller screws or smaller nails to attach the 1x to the 2x. Now you can use longer nails or screws, but they might be sticking through on the other side. And of course that could create a safety problem for anyone who's going to move the stairs. And this part is also relatively simple. You're simply going to scoot each one of the components next to the other one and then start attaching them together. So not too difficult. After these two are attached, simply slide this one over, attach it, slide this one over, attach it, and then repeat the process for the next 2 sections. And then we can go ahead and put the next 1x2 on, and of course it will be attached the same way. And for those of you wondering what size screws to use for this, maybe a 1 5/8 inch long screw. And of course, if the stairs are going to be on the exterior of a building, then maybe use galvanized, zinc-coated, or stainless steel screws. And then to assemble the other side, just simply repeat the process that I already provided you with for this side. The next step will be to install the 1x2s on the bottom. And in order to do that, we're just simply going to install the 2 on each side or at the front and the back of the stairway. And then install the other 2 on the other sides. So not too difficult. Flip the stairway back over and you're good to go. And it's not going to be that much more difficult to make the stairs a little wider. All you will need to do is to make these 2 components a little longer, and that'll be the bottom 1x2 here, or each one of the 2x6 you're going to use for the steps. Now I wouldn't suggest going any longer than 3 feet for a stairway like this, because the treads could be a little weak. And of course that isn't going to be good. You're going to want your stairs to be nice and strong. So now would be a good time for me to point out that I am planning on making a few more of these videos to provide you with a few different ways to build these stairs with handrails, with risers, and of course to make them a little wider and stronger. And for those of you out there who cannot find what you're looking for, feel free to email me a picture of the stairway you would like to build, and I will do the best I can to produce a video in the future, as long as I haven't created a video or wrote a book for that particular design. And I will leave you with a lumber list here. You can take your time and look at it. Just simply stop the video. Here is another question from one of our viewers. They were wondering why the treads on this are sticking so far out when this isn't normal. And I'm here to tell you that you can build the stairs like this if you want to. However, you're absolutely right. This is not going to be common. So most of the time, the treads are going to be set back a little bit. And that's usually going to look something like this, to where the front of the tread is back just a little bit from the top of the stringer instead of sticking out, obviously. And of course, this one here looks better. And this is the only way I've ever done it. And of course, for those of you looking for more information about building stairs with metal brackets, I do have a book called How to Build and Frame Stairs with Brackets. And I will put a link to our webpage to where you can get more information about the book in the video description comment area. Now, in order to center the tread and the bracket, or position the bracket where it needs to be, all you need to do is measure from the top of the stair stringer to the top front corner of the stair tread, and then do the same at the bottom corner and the bottom of the stringer. Or you can simply draw a couple of lines like this that would represent the front and the back, and then center the tread accordingly. And it's not going to be that big of a deal if you want to move the tread a little bit further forward or a little bit further backwards, just as long as the bracket is going to be able to connect to your wood stringer. And you could see where if you move this back far enough, this bottom bolt isn't going to do you much good. So there you have it, the most common method for building stairs like this, and the one I've used for a long time. However, it's not going to be a big deal, like I said, if you move everything forward because you like the design, or maybe you're looking for a little more structural strength, or maybe you're even using a smaller stringer. And don't forget that if you do something like this, that you might need to make changes to the bottom or the top of the stringer. And all we would have needed to do to have something like that happen would have been to remove a little bit more off of the top of the stringer. So again, the other parts of the stairway might need to be modified. Just make sure that when you are modifying these parts, that you don't create a trip hazard like this one. And trust me, I've seen these at the bottom and I've seen them at the top. Next up, let's try and figure out what they did in the first place to get the tread sticking out past the top of the stringer. And the only way I can figure it out is that they must have laid it out a little different, to where the line they were using for their tread or their riser might have represented the front of the tread, and of course that would be the vertical line, and the horizontal line might have represented the top of the tread. And then they would have just simply measured down to get the distance for the wood brackets or lumber that would have been used to support the treads. Another method that I have seen for this would be on a replacement stringer, to where they take the existing stringer and they just simply create another stringer by tracing over a new piece of lumber and then placing the stringer in place, and then starting with a level line, measuring up the height of the riser, leveling across, and then using these lines to represent the top or the bottom of the stair tread. And I'm not going to go into a lot of detail on all of that because I don't like those methods, because they often produce stairways like these that I also don't like. So again, personal preference, don't let me get carried away here, and you can do whatever you want to do. In this video, I'm going to go ahead and try and provide you with a little more information about some of the problems you might have with a narrow set of attic stairs. And of course, this would be a stairway with small treads and tall risers. And you're interested in trying to fix them, trying to make them a little safer by extending the length of the tread. And I'm here to tell you that you might not be able to do it, because you might not have enough room to extend the stairway at the top or extend the stairway stairway at the bottom because of an obstacle like a wall or something else that might be in the way. So let's take a look at the measurements for our original stairway here, and that's going to be 13 risers at 8 inches, 12 treads at 9 inches, and a headroom height of 76 inches. Now let's not forget that most stair building codes require 80 inches here. And again, you would have to check with your local building department to verify this information. So let's go ahead and take a look at this particular stairway and get an idea about what we're talking about with the headroom. That would be a measurement from here to here. The length of this stairway is from here to here, and this isn't going to change throughout the video. And of course, each step has an 8-inch riser and a 9-inch tread. Yours could be a little bit smaller. Now let's take a look and see what's going to happen if we add 1 inch to each step for this particular stairway. That will also provide us with a little less headroom also. And as you can see, we haven't changed the amount of risers or the riser height or the amount of treads, but we did add 1 inch to each step, increasing the depth from 9 inches to 10 inches and drastically reducing the headroom height, along with extending the stairway into the hallway. And even though we added 12 inch to the overall length of the stairway, the bottom step is only protruding about 6 or 7 inches into the hallway. And even though I tried to make that sound like good news, it's only going to be good news if it's not reducing the minimum width of the hallway or creating any additional building code problems for the rest of the house. And in our next example, we could be creating even a bigger problem by adding 1 step to the stairway so that we can reduce the overall height of the risers from 8 inches to a little under 7.5 inches. So here I just kind of overlaid the other stairway on top of the other one so that you could get an idea of how much we've affected every part of the stairway. So again, working with the same area here, we are not moving the top over at all, because if we could, you wouldn't need to watch this video. You could just move the entire stairway over. And some of the reasons why you might not be able to move this in the first place might have something to do with plumbing pipes, electrical wires, heating ducts, doorways, structural framing members, and of course, headroom. That could be another problem that you'd be dealing with. So for this stairway, we added another riser, added another tread, reduced the height of the risers to create a nice, safe stairway. However, we have again drastically reduced the headroom to 5 feet, and that is not going to be acceptable by most of your local building departments. So just to recap everything in the video, the biggest problem you're going to have extending the bottom of a stairway will be any section of it that reduces the width of a hallway or anything else that the building codes might not appreciate, and of course headrooms. Now, it has been a long time since I've needed to use a story pole, but I've got to say that if you're someone who's having a problem with the height of a stair step or the location of that particular stair step and even the ledger, or you just want to double check all of the measurements that you've made on a stair stringer that you have cut, then I can't think of any better way to do it than with a story pole. And a story pole is nothing more than a piece of lumber that has been divided into equal segments that will represent the individual height of your risers. And if you don't want to waste any lumber, don't cut the piece of lumber. Just simply grab an 8-foot 2x4 and mark the desired locations needed to represent each individual stair riser. And in our case, we are going to have 7.5-inch risers. So starting from the bottom, we're going to mark each section at 7.5 inches. And then we're going to use this story pole to verify each one of our risers by placing it next to the top of the stair tread. And you can see here where everything looks like it's working out at that section. And to check another section, you're just simply going to move it to the desired location. However, you're going to want to check the individual riser height for each step before you put the treads and risers on. And in order to do that, you're going to want to take your pattern and temporarily attach it in the position you think it's going to be located, and then use the story pole to check everything out. Now, if you remember, we marked the top or the overall height of each individual step. However, it might be better for you to lay out the story pole or to mark the location of the bottom of the tread or the top of the stringer, which would be this line here. And since we're going to be using 3/4 inch plywood or OSB, then we're simply going to come down 3/4 of an inch. And in order for you not to get those lines confused, it wouldn't be a bad idea to put some type of a mark in between to represent the width of the stair tread. And that can be done a variety of different ways. I like to just simply put a X in between there. Now that you have a pretty good idea how to use the story pole or what the story pole is going to be used for, I want to go ahead and remove the extra stringers because you're only going to be working with one stringer at a time, and that of course is going to be the first stringer that you laid out and cut. Now here's a situation you might not run into. However, I need to point it out, and that would be to provide you with an example of what the stair stringer would look like if you cut too much off of the bottom and then place your story pole next to it. Or another situation, and this one is going to be more common, and that will be when you don't cut enough off of the bottom of your stair stringer. So keep in mind, you need to remove the thickness of your stair tread, and in our case it's 3/4 of an inch, and drop the entire stair stringer down 3/4 of an inch. And if you don't and you install the stair stringer, then you're going to end up with something like this, all the way up the entire stair stringer. And if this happens, the upper riser or the last riser is going to end up being a little smaller than the rest of them. So keep in mind, I have the ledger in the correct spot, and everything will work out fine as long as I remove 3/4 of an inch off of the bottom of the stringer and drop the entire stringer down 3/4 of an inch. However, this usually isn't what happens. Usually the stair builder gets a little confused and places the ledger in the correct spot, and then the steps are going to be out of level. They're not going to be level anymore. But how can we check this? Simply by grabbing our story pole. And here's where we can see we're a little bit off, and if we go to the next one, we're going to be off a little bit more, but you can see where we're heading into the right direction here, right? Because once we get to the top, everything doesn't look that bad. So if you have a situation like this to where the story pole at the top is close, but there are variations throughout the rest of the stringer and you end up with something like this, then there's a good chance that they'll need to remove something off of the bottom of the stringer. Now let's take a look at another common problem, and that will occur when the ledger is a little higher than it should be, but you went ahead and cut the 3/4 of an inch off of the bottom, and you end up with something like this at the top, where you can see with your story pole that you have a problem. And there's a good chance if you have this problem that the ledger or whatever you're dealing with at the top is in the wrong location. And this is another problem you could run into if you're using different sized materials. For example, you might be using 1.5 inch thick materials for your stair treads and 3/4 inch thick materials for your floor sheathing. And this would be a dead giveaway that you might have a problem with something like that also. And either the ledger or the stringers will need to be adjusted accordingly. So again, your story pole is definitely helping you out here because everything isn't lining up, and you can see that there's a problem somewhere. And hopefully by now it's starting to make sense just exactly how important a story pole can be for a first-time stair builder. So if you're having problems figuring out anything to do with a stair stringer, you've cut it and one of the measurements isn't lining up, then do yourself a favor and create some type of a story pole and start checking everything out to see where that problem is. In this video, I will explain how you can measure a stairway to see if it's going to need a guardrail. And the most common way of figuring that out will be if you measure from the top of any part of the stairway, including the upper deck area, to the area below, and it's less than 30 inches, then you're not going to need a guardrail, but you're still going to need a handrail on every stairway with 2 or more risers. And this is according to the International Building Code Book 2000. 2018. However, what most people don't know is that you're just not simply going to measure from the edge of the stairway down to the bottom of the nearest ground. And this is even a building code that I wasn't aware of until I was doing some more research. So the interpretation I was familiar with was that you just simply measure down to the lowest spot from any point of the stairway. And if it was 30 inches or more, then it required a guardrail. And in a situation like this, you're not going to have a problem, because if you measure from the highest point on any part of the stairway to the lowest point in the soil, it's not going to be 30 inches. And it's not uncommon to see stairs like this on the side of a slope, maybe between a parking lot and a building, or throughout someone's backyard. However, if we change the slope of the hill and create a geometric shape that will help us figure out whether or not we're going to need a guardrail, then you're going to be surprised at how many stairways you come across actually need a guardrail, because someone in the building and safety department or one of the inspectors wasn't familiar with this building code. And this is usually how it goes, because most inspectors aren't going to remember every building code they come across, especially this one. However, you are going to be familiar with it now after you've watched the video. So let's go ahead and move it over. And of course, the center point here is going to be the point that we are going to use to line up with any part of the stairway. And since the top is going to create the highest point, we're going to start here. And now would be a good time to actually explain what the building code says. And it says that if you go out 36 inches and measure in any direction around the stairway on that side, and it measures less than 30 inches, so our shape here is 30 inches in height and 36 inches, it has a 36-inch radius. And you would be measuring horizontal or level out with the 36 inches. So with our shape positioned where we want it, we can see that there is a spot here that is more than 30 inches, telling us that this stairway will require a guardrail according to this individual building code. And of course, for those of you who are not going to have this shape laying around somewhere on your property, then this is how you're going to figure it out. And that will be by using a level or a level with a straight edge to create your horizontal level line, and then measure down 36 inches away from the point on the stairway that you have chosen to check the vertical measurement to see if it's more than 30 inches. So let's go ahead and remove the shape to give you an idea of what you're going to be doing. Here you can see where it's more than 30 inches. Another view of it there, and then let's go ahead and throw in another straight edge with a level to provide you with a couple of different positions that you might need to check to see if you're going to need a guardrail. And again, remember, a guardrail is not going to be the same as a handrail. A guardrail protects people from falling off of the side of the stairway, and a handrail is used for people to hold onto while they're walking up and down a stairway. Now, if you get it, you can stop the video right here. Otherwise, I'm going to provide you with two more examples. And one of those will be a larger retaining wall. And you can see here that when we go around, we can see that the 36-inch measurement is not going to create a problem for this particular design. However, it could if this wall was going to be just a little bit thinner. And you can see the problem is right here when we come off of here with a 36-inch horizontal line and then measure down vertically to find out that we are going to be more than 30 inches. Now, if you didn't want to put a guardrail on something like this, I'm pretty sure that you could just simply extend this block wall a little further. So something like this, even though it looks like it could be a nightmare, in some cases it's not going to be. And the same could be held true with something like this. If you came to a situation like this, I'm sure that you could create some type of a retaining wall or resolve the problem by simply adding a little more dirt to this area here. However, there are going to be some situations where you're just going to have to bite the bullet and just put the guardrail in. And as always, I will leave it up to you and your local building department to figure out what really needs to be done, because that's about all I have to say on this particular subject at this particular point in time. This might not be the most exciting stair building video, but I've got to make it because I continue to see people using 2x10 for long stair stringers when they should be using 2x12 or 2x14. And just recently I came across a video on YouTube that had quite a few views, along with quite a few problems, which tells me that people are still using 2x10 for stair stringers. And I don't think you're going to have a problem using 2x10 for shorter stairs, maybe less than 5 steps. But again, this is going to depend upon the amount that's going to be removed from the stair stringer when you notch it. And of course, how much is going to be left over in this area right here. So I went ahead and broke this down. Here we have a 2x10 stairway, and over here we have a 2x12 stairway. And then I made 2 separate sections. The notched section that would basically be non-structural, and the structural section here, which would represent an unmodified section of the piece of lumber. And my purpose for doing this is to try and drive this idea home that larger lumber might not always be necessary, but it is going to be stronger. And for a 2x12, we're going to end up with just a little over 5 inches, which seems to work fine for stairways up to 16 feet long. And the reasons why I'm suggesting 16 feet is because a long time ago, almost every stairway I built used a 2x12. And then sometime in the 1990s, it switched to 2x14. And it did not switch to a 2x10, which tells me that somebody figured something else out, or that they might have been having problems with 2x12. So for this design here, if we use a 2x12, we're going to end up with about 5 inches here. A 2x14, you're going to end up with about 7 inches. And a 2x10, you're going to end up with about 3 inches. And for those of you wondering just exactly what the cost difference would be between the 2x12 and the 2x10 for a 6-foot set of stairs, or a stairway using 6-foot long stair stringers, then the cost difference is going to be around $15. For a 12-foot long stairway, it's going to be around $30. So this would be a set of stairs with 3 stringers. And of course, those would be the prices in my area at this particular moment in time. Who knows, in the future, every stairway might be made out of 2x10 because the prices will be ridiculous. But for now, I don't look at $30 as that big of a difference. And I for surely don't look at it as that big of a difference if you're going to have to replace the stairs in the future and spend even more money, or you have some type of a lumber imperfection like a knot or a crack that leads to some type of structural failure in the stairway and it ends up breaking and causing an injury. And I can tell you for sure at that moment in time that you would have wanted to spend the extra money or created a structurally stronger stairway using other methods. Now, with that said, I would also like to point out that you can cut a stair stringer pattern and then strategically locate it on the piece of lumber you're going to use so that all of the knots and cracks will be located in the area where the notch is going to be cut out of the stair stringer. And that can be done by simply sliding the pattern to the right or the left, or by flipping the piece of lumber over or the pattern over and finding the best spot so that there are not going to be any cracks or knots located in the structural areas that could be the weak points in the stair stringer. Now, don't be confused. If you have a large knot in a 2x12 or a large crack, you're going to end up with the same problem, which leads me to the last point I want to make in this video, and that would be to select the highest quality of lumber you possibly can, whether you're going to use 2x12 or 2x10 for your stairway. In this video, I want to do 2 things. I want to provide you with an example of different types of wood cleats that you could use, and maybe one might work better than the other, along with the fact that I have never worked on a job where there was an architect or an engineer involved in the project who allowed wood cleats to be used. Most of the projects I worked on had some type of metal brackets that were used to connect the stringers to the stair treads. Now, with that said, I also want to point out that I have seen the metal brackets fall off and create problems for the stairway also. Which brings me back to the number one and most important part of any set of stairs, and that would be maintenance. You're not going to have these problems as long as you're maintaining and inspecting the stairways regularly, looking for any potential problems that could lead to some type of an injury. So with that said, let's go ahead and take a look at the wooden cleats. And one of the problems I'm going to have with them will be if you have something sticking past the tread like this. And I see this often. And this situation here could allow someone's shoe to get stuck underneath here or their foot and then cause them to trip. Now, is that going to be a big problem? I don't know, because you would have to actually be walking next to the side of the stairway. But again, my job is to point these things out. Your job is to figure out what you want to do with the information I'm suggesting. So one of the most common wood cleats is just a 2x4 that's even with the front of the tread and often sticks out behind the tread a little bit, or it might even be shaped, or even shaped and a little bit larger like this one here. And of course you're going to have more surface area on something like this, which will allow you to put more screws or nails into the block, making it a little stronger. And of course the standard 2x4, this is probably one of the most common ones I run into. And next on the list would be something where they shape it on one side or the other. So maybe here at a 45-degree angle, and of course this could be in a variety of different positions. Back here, all the way over to the edge of the stringer, and on and on and on. I have seen these things done quite a few different ways. And again, another idea of how they could be shaped, ending up with the back, even with the back of the tread, and then of course sticking past a little bit in both directions, and then a larger cleat where it would be shaped in the back and maybe shaped in the front. And the most common ones I see are 2x4s. I rarely come across a 2x6 or come across something that might be shaped like this. And the last one I want to show you is just a 2x4 cleat that comes in a little bit from the edge of the tread. And now for my choice, I would go with the larger cleat and try to avoid having it stick out past the front. However, if you're looking for a little more strength, you could always run it all the way back, give you a different idea of how it would work there and how it would look from above. Now, I would also like to point out that any one of the wood cleats I previously showed you will probably work just fine if you use good lumber and fasten it securely to the stringer. And then of course fasten the tread securely to either the cleat or the stringer also. And of course that can be done with nails or lag screws or even screws. And you could always use nuts and bolts with washers, and they could run all the way through the stringer and the wood cleat. However, I will not be able to provide you with a method that will work all the time, because this isn't a standard construction method approved by most structural engineers. And of course, if the method was approved by a structural engineer, then they would provide you with details for the assembly method. So I won't be able to provide you with nail sizes, screw sizes, or bolt sizes on this one. However, I will be able to suggest that this is the area right here that rots. And for some of you, you're going to want to use some type of an adhesive or sealant. And if you do, then it wouldn't be a bad idea to maybe run some of this stuff at an angle. And again, this is only a suggestion, because once you attach the cleat to the stringer with something like this, it's going to squash all of this stuff, and it could squash all this up to here and then create an area that would trap the water anyway. So this right here, I'm not 100% sold on. This idea will work better, you can see, because it's not going to allow the water to get trapped. It gets past all of this. However, before we consider using this, we need to think of one more thing, and that will be whether or not we could just simply add some type of a sealant above and forget about the rest. Now, is this going to be a good idea? Now, the one thing I have to say about some of our great ideas is that they can create problems for us. And you can see here that if you use some sealant to seal the top of the cleat and then use some more sealant for some additional insurance, and something like this is going to work great. However, that might not be the case if you install your tread here, because now we're going to have an area that could trap water. Any water that gets between the stringer and the tread could actually get trapped in this area. And of course, I'm pointing this out to prevent some of you from doing this, when in reality, all you would need to do would be to put some sealant above here. And I understand that if you don't want any sealant, maybe you're going to be staining the stairway, then in reality, it might not be necessary to apply any sealant and accept the fact that water is going to get behind this area, and if it remains trapped there for a long enough period of time, then it will probably start to rot the wood where the wood is in direct contact with the other wood. And again, this seems to be one of the biggest problems with this type of stairway. So one thing you could do would be to seal the top and the front of each one of the treads and wood cleats all the way up the entire stairway, and then maintain it. Actually inspect the area regularly, maybe 3 or 4 times a year. You know, if you live there, you can inspect it almost every day while you're walking up and down the stairway. So before I end the video, let me leave you with the 2 major points. One of these is that you don't see structural engineers doing this very much. They're usually using metal brackets. And I have a book you can get at the website on how to build stairs with metal brackets. And if you want to get a little more creative, I also have a book on how to router out or dado the stair stringers so you don't need to use metal brackets or wood cleats, because the treads will actually slide into the slots in the stringer. And this is actually one of the best ways you can build a stairway like this. But again, this will depend upon the area where you live, how much snow, how much rain, how dry it is, and stuff like that, because there could be some other problems that I'm not going over in this video for a variety of different stairways. In this video, I am going to provide you with a couple of methods you can use to fix a stairway with treads sloping either backwards or forward, even though I'm only going to provide you with an example of a stairway with the stairs sloping backwards. So let's go ahead and take a look at a stairway that is built correctly and has equal-sized risers going all the way up the stairway. So here we can see where we have 7.5-inch risers all the way up to the top, with a overall riser height of 4 foot 4.5 inches. And level steps. Everything is right on the money. Next up, let's take a look at a stairway where the treads are going to be sloping backwards. And of course, I left the level in the original position so that you could get a better idea how the stairs are sloping. And in order to create the sloping stairway, all I did was took the stairway and angled it down about 1.5 inches. And of course, I'm not about to suggest that this is what your stairway looks like, because this problem can be created a variety of different ways. Now, in the first method I'm going to suggest using would be to simply remove the treads and install some type of a shim or wedge underneath them. And of course, that would look something like this, where you would simply grab a level and put it on top of the riser, and then level across to the front of the riser here, make a pencil mark, and in this case, I believe it's about 3/8 of an inch. So you're simply going to cut a wedge. It's going to be this long, from basically 0 to 3/8 of an inch. And then, of course, you could place them accordingly as needed in the stairway. And then, of course, you could use adhesive or some type of glue between the stringer and the bottom of the shim, and then again on top of the shim and underneath the tread to create level steps. However, by raising the back of each step, you could create a problem down here at the bottom. However, before we take a look at that, let's take a look at the new overall height of our stairway, which is about 1.5 inches less than what we started with. And all of the treads have been leveled. And we now have risers that are 7 1/8 inch tall. And this would be all the way up the stairway. Now, another problem you're going to run into with something like this will be the fact that the risers are no longer going to be square. So for example, if the treads were sloping backwards, then you can see here where you're going to have a gap at the top. And if the treads were sloping forward, then you're going to have a gap at the bottom. So again, they're not going to be square. And depending upon how much they're sloping will depend upon how much out of square they're going to be. And of course, that is only one of the problems. The next problem is going to be the very bottom of the stairway. And here you can see where we're almost off a half of an inch. And again, this could vary from stairway to stairway. So if, for example, someone noticed that there was a gap at the bottom of the front of the stair stringer like we have here, and then went ahead and altered the stair stringer by cutting it level and dropping it down, then you might not have a problem. But of course, this means you would have had a problem to begin with because your bottom riser would have been smaller than the rest of them. But again, let's not rule that out, because you need to be aware of the fact that whether the treads are sloping forward or backwards, and you adjust them with your shims, and you could end up with a problem either at the top or the bottom of the stairway, like we have in this particular stairway. So here everything is working out at the top, and it should make sense because we have the shim here and it matches the other steps in the stairway except for at the very bottom here. Now, since this could actually be a problem, I will provide you with a second method, and that will be to use a story pole. And a story pole is simply a piece of lumber that you can cut to match the overall height of the stairway, or the total rise of the stairway, and then divide it into the amount of risers for that particular stairway. And in this example, we have 7 risers. So if we divide 7 into 4'2" and 13/16", or 50 inches and 13/16", we will end up with a riser height of about 7 1/4 inches. And if you remember, in the previous example, we had 7 1/8 inch risers, but in reality, we need 7 1/4 inch risers. So this is actually another problem, or should I say, could be another problem. But once you have the story pole and you use this method, you're going to create equal size, consistent risers throughout the entire stairway. And that's going to be done by adding or subtracting materials, like you can see here in the top step, where we're going to need to add a little bit of material to the back of the stair step. However, that's not going to be the case for the front of the stair step, where we're going to need to remove about 1/8 of an inch. And this might require you to remove the riser and rip it down 1/8 of an inch. And then you're simply going to work your way down each individual step. And it might even be faster for you to remove all of the risers. But again, that's going to depend upon the problems that you're having with the steps, and how much you're going to need to be adding or removing, and how you're going to go about removing the materials. So for example, here you can see where we're going to have to remove some of the stair stringer, and that's exactly what you're going to have to do here. So here you can see where we're going to have to remove almost 1/2 of an inch off of the front and almost 1/4 of an inch off of the back. And of course, this would require you to remove all of the risers and then use a circular saw or another tool to remove some of the lumber from your wood stringers. And if this sounds like a lot of work, then you're absolutely right. However, I did want to provide you with an example of this if you only have a few steps that you need to adjust. However, if you have a longer stairway, then you're probably going to want to remove all of the stringers and then cut them to where each step is going to be the same size and, of course, level. In this video, I am going to attempt to prove whether or not it's going to be better to run drywall vertically or horizontally to reduce the amount of taping that would be required. So this would be taping and finishing at all of the joints. Now, what inspired me to make this video, and you can feel free to add your 2 cents in the comment area, is that about 20 years ago, I was working on a tilt-up building. And tilt-up buildings usually don't require any interior structural walls, which means it can be ran in either direction. And of course, this is the first time I noticed drywall ever being installed vertically, which inspired me to ask the drywaller why they were installing the drywall vertically and not horizontally. And he said it was to reduce the amount of taping and finishing required on the project. And even though I didn't really buy into it 100%, I never ever took the time until right now to figure out if that was actually true. So let's go ahead and see who's right. And with this experiment, I am going to provide you with a few different wall sizes and drywall layouts. Starting with an 8-foot by 8-foot wall, which you can see there is going to be no difference. We have one 8-foot long seam on each one of these. So 8-foot wall by 8-foot wall is a tie. However, on a 10-foot long wall, we are going to have a winner, and that's going to be by at least 2 feet. And basically that 2 feet is going to be represented in this area right here. So for example, if we only added 1 foot, if this was a 9-foot wall, then this would be 1 foot long. We would have 1 extra foot to finish. And if it was 3 feet longer, we would have 3 extra feet to finish. And for those of you wondering just how big of a difference it's going to be for an 8-foot wall, I can tell you that you can go as long as you want to. And if you don't have any openings in there, any doors or windows, then you're not going to have more than 4 feet to finish, whether or not the wall is going to be 12 foot long or 120 feet long. As you can see here with a 12-foot long wall, or a wall that's 16 foot long, 20 foot long, again, 4 extra feet, and of course a 40-foot long wall, 8 foot tall, 40 foot long, 4 by 8 sheets of drywall ran in either direction. We still only have 4 extra feet to finish, and that might not make all the difference in the world or be enough for me to switch from one to another. And if this is going to provide me with more structural strength, then I wouldn't even think about doing this. However, things start to change once we go to 10 feet and we're still using 4 by 8 sheets of drywall. As you can see here, we have 130 feet and 126 feet of taping and finishing to do at the joints. But again, we're only 4 feet more in either direction. I don't think that's that big of a deal. However, again, we're only 4 feet off here. However, this is not going to be the case if we use 4 foot by 10 foot sheets. And of course, you can see the difference here. It looks like it's about 26 feet. And this is actually the example that I was referring to when I said that I was talking to the drywaller and they were installing them vertically. They were for 10-foot tall walls. And I remember they were going to have a 9-foot T-bar ceiling in them. So something like this, again, seems to make a little more sense if it is not required to be a structural wall. Now let's take the same wall, 10-foot sheets, but we're going to switch these to 12-foot sheets. And you can see we only lost 6 feet here. So again, not that big of a deal if you're not interested in lugging larger sheets of drywall around. Now things start to switch up a little bit if we're using 12-foot sheets horizontally and 8-foot sheets vertically. And we can see here again where we're about 8 feet off for these two walls. So we've actually reversed, and this one here is no longer the winner. But again, we're back to an 8-foot wall and not a 10-foot wall. Now let's go ahead and throw some openings in here. And of course, these are just estimated linear footage numbers. But again, you can see where we're not that far off in either direction with something like this, where the windows and doors are located in these positions. But that's not going to be the case if we move them over a little bit, which provides us with a good example of how all of this can be affected by any openings located in these walls. And with that said, we are now at the end of our video and the end of our experiment. Feel free to let us know about your experiences, or if this is something like me, you really never gave much thought to, but now you have the real numbers in front of you and realize that it really might not make a difference whether or not the drywall is ran horizontally or vertically. Here is a question that someone sent who was having a difficult time cross-measuring so that they could square a patio slab they were trying to build, or should I say at least the forms that they were putting together for their patio slab. And hopefully by the time you're done watching this video, you will understand exactly what the problem is. Now, in order to cross-measure anything, a square, rectangle, to see if it's square, all of the corners are square, the surface area needs to be perfectly flat and on the same plane. So this would be a flat surface. Now you can have it level or angled like we have here, but it's got to be flat. flat. It cannot have one side dipping down, which you will see here in a moment. So here we have a flat slab. We just took the one that was on the other side over here and then dropped it down a foot. Now I know you're not going to be dropping it down a foot. I shouldn't say that. I don't know that you're going to be dropping it down a foot, but this is what we're going to be working with. So I took a flat surface here and then just kind of dropped it down a foot, which gave us this. So now I'm coming from this point here up to here. These two parts are level. So we have this part and this part is a level and flat surface if I was going to go from this corner to this corner here. And this is the problem that I believe the individual asking the question was having, is that they were not working with a flat surface. They were working with a surface that was kind of jacked up like this. And hopefully the individual's name is not Jack. But you can see here that if we cross measure all of these from this side here, we're fine. If we do it from the other side here, we are not going to be fine when we come over to here. And if you were cross measuring something, this is going to give you the idea that this might need to move in one direction or the other, when in reality that might not be the case because you have a sloping surface on one side. And of course it would make sense that the length of this side and this side will increase the further we drop this section of the corner down. Or for example, if we were going to raise it up. This is another video that I am going to attempt to try and provide somebody with some information about who has a situation like this, where they have a raised section of the house and a lower section, so kind of like two different floors, or a situation where you have framing here. So this would all be wood framing covered with some type of siding or stucco, and this area here would either be a stem wall or part of a foundation. Now I have it drawn in as a block wall, and I guess that the individual is having a problem with erosion or just wants to do something a little different to the side of the house. And what they've done is sent me pictures where they have removed the siding here and installed some type of a cement fiberboard. And that's fine, but you're going to need some waterproofing if you're going to raise the level of the soil or have soil that's going to be above the framing break line, which would be above the foundation. And since a lot of people have a difficult time visualizing the end result, I went ahead and drew a couple of situations that might be helpful. And one of those would be to build a block wall or some type of a retaining wall here. And then of course you could pour two concrete sidewalks. You don't need to pour anything like this. You can make it smaller or wider. And of course have a set of stairs that you can use to go between the levels. And all of that might work out just fine, but I believe the individual had a gas meter here, and you might have an obstacle too that you can't remove. And in that case, you can always move the wall back. And of course, you could move the wall all the way back to here if needed. And of course, there would be a set of stairs that you could use to take you between the two levels. Or you can do what I think the individual was trying to do, and that was to backfill the entire area. However, in order to do that, you're going to need to waterproof everything. And I don't recommend just waterproofing a section here, because once you raise the level of the soil and you get one little teeny crack anywhere in between where you stopped waterproofing, then you could end up with a water leak. And a water leak, of course, is going to cause the wood framing to rot eventually. And again, in a situation like this, you could move the retaining wall in a foot, you could move it in 3 feet, you could move it in 4 or 5 feet, or even enough to build a stairway to where the bottom of the stairway would finish about here. So in our first two examples where the block wall is going to be behind the foundation on this side, then you're probably not going to have a problem. But you could have a problem, like I said, if you do something like this and you don't waterproof this properly. So again, not too difficult of a situation to end up with a lot of problems if you end up doing something like this and this isn't waterproofed properly. In this video, I will be reviewing one of my books I have just updated, Professional Stair Building Secrets. This is the second edition. which was updated from the original version written in 2012. This one is written in 2020. And we will be taking a look at the paperback version, the ebook version, which is available at a variety of different online retailers. If you have your favorites, just simply type the title in and see if it's there. And of course, you can always check out some of our other books that we have. Go to the website, homebuildingandrepairs.com, and then there will be a link to our books on almost every single web page. Next, let's take a look at our table of contents. Here we have a few chapters, and I'm going to go over some of them to provide you with a better idea of what you're going to find in this awesome book. Now, first up on the list, how to create an undercut instead of an overhang. Now, I don't have a nosing or an overhang on this stairway because this tread is even with the face of the riser, just like this one here. But sometimes you're going to have a 1-inch overhang. And as an alternative to a 1-inch overhang, to create a larger step, for example, here we have a 10-inch step, and here we have an 11-inch step. So to create this, I just simply need to extend either the top or the bottom in the direction to provide you with a larger tread. So you will learn how to do that in this book. And of course, here's another handy tip for anyone who's planning on building an exterior stairway that will require some type of waterproofing materials to cover it and prevent any water from accumulating on the steps. For example, I will show you how to actually slope each step just a little bit to prevent water from accumulating on these steps. And in another chapter, I will provide you with a few more reasons why stairs might be squeaking and how you can use different materials to reduce or even in some cases eliminate any possible noise caused from the assembly and construction of the stairway. So this isn't an uncommon problem, but it is extremely annoying. And as a professional stair builder, your stairs should not be squeaking. And here is another problem that I run into often that seems to be difficult for most stair builders to wrap their minds around. And that would be how to line up stringers perfectly so that the last step or the face of the riser lines up with a wall, or maybe is set back an inch from the edge of a wall, or in some cases lines up perfectly with a desired measurement on the floor plan. And of course, what's good for the bottom is good for the top. I can't tell you how many times I've came to a stairway where the face of the nosing or the face of the riser is located in the wrong spot. So hopefully by the time you finish reading this book, you will have a crystal clear understanding to prevent a problem like this from ever happening again. Another tip in the book that you might find helpful will be a few different ways you can make stronger guardrails when you're framing them out of 2x4 or 2x6. And for those of you watching this video, here's your free tip without purchasing the book, if it actually makes sense to you. And that would be to simply extend a riser past and attach it to the 2x4s that are going to be part of the guardrail framing, as you can see here. So again, there's your free bonus tip for watching the video, along with this method over here on how you can force a stair stringer down. That is, if you could read all of this stuff. So anyway, there are your free tips. Another interesting chapter in the book will be to help you figure out the precise location of a footing, floor, or a landing that might be located somewhere within the stairway, or for example, for an exterior deck. And if you're looking for precision, by simply pre-cutting the stringer and then placing it in the desired location, you will be able to figure out how to locate the lower landing on a variety of different types of stair building projects. And with that said, I am going to wrap up my review on this book. I wrote it, and it will be your job to read it, especially if you're interested in improving your stair building skills. And I do realize that there is information in this book that is going to make you a more efficient carpenter and a better stair builder, and somebody who could be in more demand by contractors in your area who are familiar with your abilities. And this is actually one of the reasons I made a lot of money in the construction business, because I knew how to build a variety of different stairways. And keep in mind that if you don't know very much about stair building, however, you're interested in making the big money that can be made as a master stair builder, then I would definitely check out some of our other books, especially on circular stairs and routed out stringers. And don't forget to visit our website and check out some of our other videos about a variety of different things related to the construction industry, like house framing, plumbing, electrical, decks, patios, you name it. If there's something I have knowledge about, I'm trying to share it with people, especially those people who are sincerely interested in improving their skills. And one of the ways to improve those skills is to read books and watch videos.